Hey, all right, how do we solve systems of linear equations using elimination? The goal of this method is to eliminate one of the variables by adding the equations. And what I really like about elimination is that you are totally in control of everything. We can do elimination in 3 steps. The first step is going to be multiply one or both equations by a constant. A constant is just a number. To obtain coefficients, the numbers in front of the variables, that differ only in sign. So that just means you need one positive and one negative. Okay. Step 2 will be to add the equations, and combining like terms will eliminate one of those variables. And then you'll just substitute that value into the original equations. So take a second, write all that down, and then let's see what that looks like. One last note is to use this method when both equations are in standard form. That's when you have the variables on one side and the constants on the other. All right, here we have the system 6x minus 8y equals 8, and negative 6x plus 14y equals negative 20. So step 1 is multiply one or both equations by a constant to obtain coefficients that differ only in sign. Well, if I look here at my x's, I already have a 6x and a negative 6x. So they both have a 6 in front of the x, and they differ only in sign. This is positive and this is negative. So for this problem, I can skip step 1. Step 2 says to add the equations. So the way I'm going to do this is I'm just going to draw a line, and I'm going to add these equations. 6x plus negative 6x is 0. So these things eliminated each other. That's why this is called the elimination method. Negative 8y plus 14y is 6y. And then drop the equal sign right in between. 8 plus negative 20 is negative 12. So I don't really have to write 0 plus, so I'm going to get rid of that for a moment. Dividing both sides by 6, I get that y is equal to negative, y is equal to negative 2. So now I already have my y value. The last step is to substitute this value into either of the original equations. It doesn't matter which one. So I just go back to my originals and I go, okay, 6x minus 8, now y is negative 2, so times negative 2 equals 8. That's 6x, negative 8 times negative 2 is positive 16 equals 8. Subtract 16 from each side. 6x equals negative 8. And after we divide by 6, negative 8 and 6 both have a 2 in common. So this reduces to negative 4/3. X equals negative 4/3. So now I have an x and a y. I could plug both of these into the other equation. They're going to satisfy that equation as well. So my solution is negative 4/3, negative 2. In this next example, we have 4x minus 2y is equal to negative 16, and negative 3x plus 4y equals 12. So really the first step should be choose a variable to eliminate, because as of right now, if we were to add these two equations, nothing would eliminate. So if I were to multiply one or both of these equations, 4 and 3, the first number that they both go into is 12. So I'd have to multiply the 4 by 3 and the 3 by 4. But if I look over here at the y's, I see I already have a negative and a positive, and this is a negative 2 and this is a 4. So what could I multiply this first equation by to get a negative 4 up here? Well, I could just multiply the entire equation times 2. Now, I have to remember, I have to multiply the entire equation, right? Because with equations, whatever you do to one side, you have to do to the other. So now I would have 8x minus 4y is equal to negative 32. And the second equation, we just kept the same. So it's just going to come over. So negative 3x plus 4y is equal to 12. Whenever I add these equations, I get 5x plus 0 is equal to negative 20. Divide by 5, and x equals negative 4. Now I just go back to either of my original equations. I'll just plug it into the first one. 4 times negative 4, since that's our x value, minus 2y equals negative 16. So negative 16 minus 2y equals negative 16. Add 16 to both sides. Negative 2y equals 0. So if I divide this by negative 2, I'll end up at y equals 0. So I've got an x and a y. My solution is negative 4, 0. All right, so let's go ahead and you give it a try. Here's a system, negative 2x plus y equals negative 9, and 3x plus 4y equals negative 14. Go ahead and pause the video, and then check your answer in a moment. All right, there are a number of ways you could have done this. The way I chose was to multiply the y, this whole thing, by negative 4. To get 8x minus 4y equals 36. I added my equations. I solved for x, and I got x equals 2, plugged it back in, and the solution was 2, negative 5. Sometimes it's not very apparent what you should do whenever you have a system. So sometimes you have to just multiply both equations. It doesn't really matter if you want to eliminate x or y. I always try to do the thing with the smallest multiplication. So I'm going to use x because I have this 3 and this 4 versus a 6 and a 7. I already have one positive x and one negative x, so I'm not going to have to multiply by any negatives. But to get 3 and 4 to eliminate, the first number that they multiply into together is 12. So this equation, I'd have to multiply times 4. And the second equation, I'm going to have to multiply this one by 3. So let's see what the new equations would look like. 3x times 4 is 12x. Negative 6y times 4 is negative 24y. Whoa. And people seem to forget this other side of the equation all the time. 9 times 4 is 36. Okay, now multiply everything in the second equation by 3. All right, now let's add the equations together. The x's are going to cancel each other, so I have negative 3y is equal to negative 12. Divide both sides by negative 3. Negative divided by negative is positive 4. And then remember, just go back and plug these into either of the original. So 3x minus 6 times 4 equals 9. 3x minus 24 equals 9. I'm going to add 24 to each side. 3x equals 33. So x equals 11. And the solution is 11, 4. Finally, I'm just going to talk about special cases for a moment. We've already done a lot of examples, so you can see this 4x and 8x. If I wanted to cause them to eliminate each other, I'd multiply this 4 by negative 2. But whenever I did that, everything eliminated itself. And I ended up at 0 equals 0. So if you eliminate everything, but you end up at 0 equals 0, which is a true statement, you'll have infinite solutions. Infinite solutions just mean these are the same line. Now, if you get into a situation where all the variables eliminate each other, so you have 0, and they're equal to just any other number. So like here I have 0 equals 2. That's not true. This is no solution. So these must be parallel lines. And that would be your special cases. And that's everything for elimination.